I'm Frida with Robots Daily. Here I'm currently on site of ICRA 2026. This stand is from Rysen Robotics. This is Mr. Lee. Hi, Mr. Lee.
Hi.
Can you give me a short introduction about your company?
Sure. Right, so our name is Rysen Robotics, and we are based in Shenzhen, China. And it's the first time here at ICRA 2026. And welcome to our booth. So I'll begin with sharing to you our product. It's called the Apex Hand. It's 21 degrees of freedom with 16 active joints, right? So over here you can see we have a very good workspace. You can basically cover the entire working range of the human hand, right? And it's very fast as well, right? But the reason why we designed the hand is not just because of speed and dexterity. We feel that when it comes to real-world applications, you need the hand to be also very robust and strong and impact resistance. Because many of our customers, the feedback is that most of the hands today, they are maybe good to for very delicate lab use, but in real world you encounter many other issues like unexpected collisions, or maybe you need to grab some heavy objects. These are also very important aspects that the hand should have if you want it to be used in the real world, right? So over here I'll demonstrate to you. This is a tele-operated setup. So my colleague here is controlling the hand using a glove, right? Okay. And now he's going to right? So you need a lot of strength to actually hold the tool properly. And when what's going on is not just the strength, there's a lot of impact that gets transmitted back to the drivetrain. And our hand is able to withstand all this. As a demonstration on the robustness of the hand, what I'm going to do is I'm going to smash this board into the hand, and you can see that it's going to be able to resist all this impact. Okay, continues to move. One more for you.
Whoa!
All right. So moving on to here, as I mentioned, you can see that we need a lot of power grasp. And how strong is our hand? This is a very heavy payload. I cannot hold this for long enough, right?
Wow.
This is how strong our hand can be. And I have the thermometer over here that tells you that I can do this all day without overheating. Because our design philosophy is that this is built for real world. We have active cooling built into the hand. There's a fan that can dissipate all the thermal energy out, and this can be held for long hours, right?
What is the maximum holding?
For hook grasp, we can go up to 30 kilograms.
30 kilos.
And for the vertical grasp, this is actually tougher. It's up to 10 kilograms. Right. The reason why this is more difficult is because it's by friction, and you need to have a continuous force output in order to maintain the grasp. But it's not that every day we expect the hand to be lifting heavy objects, but from just now the demonstration, you can see when you're using tools, you need a very strong grasp to achieve the rigidity and use the tool properly. Right? If it's a sloppy hold, then you won't be able to do this job. Right.
Oh, wow, amazing.
All right, so see, it's been going on for a while. Let's leave it there. Let's move on to the next segment. Besides the speed, dexterity, strength, and durability, we also have full skin tactile sensing. Right? We develop our own electronic skin that covers the fingertips, the inner phalanges, the palm, and the thumb. Right? So these are actually electronic skin that we develop in-house, and they cover the entire surface of the curvature. And it's also very important when you are grabbing objects, because you need to know not just in the fingertips whether you're contacting, because most of the time when you handle objects, it's the whole hand that is in contact. It's a multi-point contact problem, and you need the tactile sensing to be coverage to be as good as possible. Yeah.
So why should be this hand for the full sensors? Why? I mean, why should this hand should be have this full hand sensor?
So when you are doing manipulation, we need to do what's important in manipulation is to be able to alter the pose and orientation of objects in your hand. We call this in-hand manipulation. And when you're doing in-hand manipulation, what happens is you're using multi-point contact. You're not just using the fingertips. You're using your whole hand to actually achieve the level of to interact with the object. And you want to be able to sense all the force interactions that is going on between the hand and the object. And that's why we are trying to achieve as large a coverage as possible with the Apex hand.
Okay. So in this one hand, it has full sensors, and this one has.
It's an option. Some of the customers for their application, they may not want to have the touch sensing.
Yeah.
It depends on the customer needs. Yeah.
Okay.
Yeah.
It can be made by depend on the customers.
Yes, we have some customization options available.
Yeah. So which company have you already coordinated? Right.
We are currently ramping up production. We have a lot of customers from academia. That's why we are here at ICRA. We have companies, university professors. They are trying out applications.
Okay.
We also have some automotive customers. They are trying to lift and pick and place objects, parts. Yeah.
So I see here are many other exhibitions. Will you participate?
Yeah, we will be in a number of exhibitions, both overseas and also in China.
Yeah, I see. So you also will participate in CES, right?
Yeah, we are planning to be at CES by early next year.
Yes, we can see in CES in January 2027.
Yeah. Hope to see you there.
Yeah. So, did you have any other introductions for products or companies on other side?
Other side, you.
Yes. I mean, you have other introductions to right now you have introduced your hand, right? And what about the most important specifications of your hand?
Oh, the specifications of the hand. Most of the customers, they will be interested in like the degrees of freedom, like you see over here in our display. We actually we want to market the hand as an all-rounded high performance system, where we are able to achieve all these specifications in one product, right? So, like we have seen just so far, this is showing off the dexterity, the workspace, the flexibility, and the number of degrees of freedom of the hand. And then we also show that it is very strong. As you can see, it's continuously holding up. It's still going strong, right?
It can hold all day.
It's also very fast, right? You can see over here we are able to achieve sub 0.2 second cycle time, right? And this is also in part due to our very high control loop frequency. We are able to achieve 1 kilohertz control. It's an Ethernet communication. We have absolute encoders in all of our joints. This allows it to achieve very high precision even after long periods of use. So this hand has been on for a number of days right now, and as you can see, it's still able to achieve very high precision location. Yeah, so it can still touch all the fingertips and all that. This requires very high precision encoders in the hand. And we have shown you the tactile sensors, and the robustness as we've displayed, ability to withstand all these accidental impacts that are actually very common in many applications, including like data collection, teleoperation. If you look around, there will be in data centers, you will see that most of the collection desks, they actually have a thick cushion, and that's to prevent their end effectors from colliding with the table. And you don't get that luxury when you are at the customer side, right? The customers, you just book whatever is provided, right? So the hand has to be able to adapt to all these requirements.
Yeah.
Yes.
That's why you told us it should be in the real world.
Yes, we believe this day will come, and I'm sure we are prepared for that.
Yeah.
Yes.
So, do you have any technical challenges right now?
Of course, this is a long-running kind of development. I believe right now the first step is to get a good hardware that you can use, and the next step will be the data collection and the intelligence part. Right? Before this can be actually, when everybody can use this technology, you need a combination, the full stack of technology to be mature. This includes like the algorithms, the good high quality data, both from humans and from teleoperated data. All these have to be ready. Right? So it's still a long way.
Yeah.
Right? But the first step I believe is to have a good hardware that everybody can access and use in their real environments, and that's where you can get the high quality
step
data.
By step.
Yes.
Okay. So, might know the price of this one hand?
The price of the hand is a good question. Currently, highly dexterous hands, they are not cheap. This one I have to be honest. Right? We have many of our competitors around the same price. We currently are selling for international customers $20,000 US per hand. Right? But for education customers, we can do a discount. In China, it will be priced accordingly because we are based in China and it's easier to support customers from there. We want our customers to have a good experience, basically to ensure that they have low downtime. So even I'm not saying that the hand is indestructible. It's reliable enough for today, but in the future there's a lot of improvements to be made. But if and when customers run into problems, we want to be able to respond quickly. So we have to have the kind of margin to allow us to provide the level of service that our customers expect. Yeah.
Is there any other after-sales service?
Of course, there will be a lot. Right? I mean, most of the customers, they hope to run their data collection 24/7, for example. Then if anything goes wrong with the hardware, you have to be able to respond quickly. Yeah, so after-sales service is a very important aspect of that we will focus on. Yeah, we'll invest in a good relationship with the customer. Yeah.
So, what about your globalization plan in the future? Globalization, make your company more international.
Well, the first part is actually to get more publicity, and we are very thankful that you guys are helping us to kind of give us a platform to showcase our technology. We are here in ICRA is to show our very important customers, which is academic professors and our industry partners, that what is possible with our hand. And this will continue to do this through maybe real life demonstrations as well as through more publicity channels that will come. Yeah. And besides that, we hope to actually have a good relationship with our researchers who are actually trying out the applications, because I believe what's important is that people need to see what is possible with this technology. Right? I mean, there has been a lot of news about many of similar kinds of products, but we hope to go in and solve real problems. Right? So we hope that our customers can use our product in their actual applications and make a difference. Yeah. And I believe that will sell much stronger than just launching PR videos. Yeah.
I believe you will be successful in the future.
Yes.
So thank you, Mr. Lee.
Thank you so much for your time.
Hope you great success in this role.
All right. Thank you so much.
Thank you.
Yeah. Have a nice day.